I would encourage you to work ahead.
Which
It's
link?
good. The link that's on.
What? When did you deal with that?
Weeks ago, wasn't it?
When you want listening.
Yep.
Okay.
Right, B6 now. So, what is resistivity? Anybody? B6, A1, resistivity?
This is
each material has
Yeah. It's almost just need a bit more.
cross-sectional area.
Yeah, but like I mean, there's a few ways to define it. One way to define it is you remember the formula. So that's rho L over A. Yeah. So resistivity will be A or over L. Yeah. So I mean, there's many actually definitions. So one definition you could go for is with the formula, but with this definition, you have to then state what each term in the formula is. I mean, that's one way to do it. And looking at the marking scheme, that's the way he went for it this year. But he also says that other suitable definitions are fine. So the one I gave you in class was resistivity is a measure of the amount of resistance the material offers per, and then whatever the unit was, per unit cross-sectional area, something like this. So I would go with this resistivity is the resistance offered. Pen, come on. Resistivity is the resistance offered by a unit length of material with a current passing through a unit of cross-sectional area. As an example. Yeah. Continue. Next part. So the next part is a calculation of resistivity. 2.645 What's 2.64? The answer? Sorry, bad news. It's not this. Hey, at least he's trying that at home. What have you been doing? Catching up on Flash?
Chemistry.
Yes.
Yes. I did the assignment she gave us, teach you.
Who's time?
You have your answer.
No, you already summarized the assignment.
Which assignment?
Science homework.
Homework.
That's not assignment.
What is it?
The password question.
What is it?
The one we did just today.
It's a homework, not an assignment. She's not going to grade it, is she?
Yeah.
Are you going to grade this?
Oh no.
That's not assignment.
No.
So what is it?
Homework,
It's-
practice.
The same thing. No, I have it.
Good for your health, that's what it is. Alright.
Chemistry, he didn't do it good for his health as well.
What? Chemistry's great for your health. Okay. Next one now. The length is 2 meters. The resistance is 10 ohms. The diameter is 1.1, oh sorry, that's not the diameter. The resistivity constant is 1.1 micro ohms meters. And the question is, what's the diameter? So, what's the area, basically? So, R equals rho L over A. So, A equals rho L over R, which equals 1.1 times 10 to the power of minus 6 times 2 times 10. So, the area is 2.2 times 10 to the minus 7 meters squared. But what's the formula for area? Pi r squared. So we can easily get the diameter here. If I divide by pi, square root the answer, and then multiply by 2 for diameter. You see, you forgot to multiply by 2.
Why?
Huh?
Why?
Diameter, not radius. Ah. So the diameter is in millimeters. 0. Multiply this answer by 2 because you're getting the radius. Half a millimeter.
So my answer is radius.
Yeah. Congratulations. You will get 2 out of 3 marks. Actually.
We've done this question like 10 times.
Yeah, so we'll go through it really quick so we can have all the videos together. Part 3. Right, so
0.5.
yeah, we can do this one super quick. I want the length L1 and L2, and what's the total length for this potential divider? 2 meters, is it? And how much resistance do you want on the top?
5.
Right, hang on. Oh, it's the voltage. Yeah, sorry. Sorry, let me just redraw that. Yeah, what is it taking? You want on the top half here to here to be 9 volts, and then on the bottom half you want 3 volts. So if I call this length L1 and L2, the lengths are in the same proportion as the voltages. So you know that L1 to L2 must be equal to 3. Yeah? What else do you know about L1 and L2? L1 plus L2 should equal 2 meters. Do you have enough information now to find L1 and L2? Yeah, because you can just change this into L1 minus 3L2 equals 0. So if I solve this linear system, I get 1.5 and half a meter as the 2 answers. So I get L1 is 1.5 meters and L2 is 0.5 meters. Okay, part 4. 5 ohm is connected. Right, so can I go down? Yeah. So we have our picture now, look. This one here, but now there's a 5 ohm resistor here. Now I haven't worked out the resistance yet, but look, this is R1 and this is R2. Now we actually know what the total resistance is. What is it? It's from the previous question. It's 10. Yeah? Also, you know that R1 over R2 will equal, it's the same proportion, it's 9 over 3. So that's the same as 3. So you have R1 minus 3 R2 equals 0. Do you have enough information now to get R1 and R2?
Yes.
You do. So once again, we solve this linear system. And I'll get R1 is equal to 7.5 ohms, and then R2 will be 2.5 ohms. What is the resistance, what's the R1 here? 7.5. What's the R2? Well, it's not really 2.5 because you have two resistors in parallel, so we need to combine these, okay? 1 over R equals, now, to prevent confusion, I'll call this one R2, and I'll put a little, I don't know, I'll put a little tick here to mean it's not really R2, it's only half of it. There's another resistor here. So 1 over R equals 1 over 2 R2, 1 over 2.5 plus 1 over 5. So I get R2 equals 1.67 ohms. So now that I have my R1 and R2, I can use my potential divider equation. Do you remember the one that's V out equals R2 over R1 plus R2 times V in? And the V out is the voltage on the outside here of these two. Now, do we know R2? We do. What is it? 1.67. And what's the R1?
7.
Very good. And what's the input voltage? 12. So, the answer is 2.19 volts. Which is correct. Next.
Why do we use the R to be 1.67, not 2.5?
Because that's not the total resistance on the output. On the output half there are two resistors. Is there not?
Mm-hmm.
So, what's your question?
Okay.
No, really? It's okay?
Yeah.
You sure?
1.31 hours.
For which one?
5.
5? What?
You're sending in advance.
Oh, there's more to this. Yeah, part 5. What's the current? Okay. The current. Okay, the current, yeah. Oh, that's okay. Here. What's the voltage supply?
7.5.
No, the total voltage supply is 12.
5.
What's 5?
What's the number? 0.6.
Oh, sorry. Wow, okay, that's really, okay, fine, yeah, 5. 12, and we want the current. Now, we have the R2, what is it?
1.67.
1.67, good, thank you. And then the R1?
7.5.
7.5. So in fact, what's the total R? It is 9.17. Yeah? So I'll just use my VIR triangle. And what's the I? V over R, yeah. 1.31 amps. Which is correct. Yes it is. Okay. And then the next part, what's the current flowing through CB?
0.8.
Yeah. Well, if we look at the CB part now, here's the CB part. Now, what's the voltage here, though? What's the bottom voltage? We said it was 3 volts for the bottom half, wasn't it? Is it still 3 volts though?
Might change because we have the
Yeah, I think you're right. So I don't think we can necessarily say it's 3.
Yeah, can we find the voltage for the top part?
Oh yeah, we know the voltage for the top half, so if we minus it, we have what it is. What was the voltage of the top? Did we work that out? No, actually, hang on. Part 4 was calculate the potential, the voltage across the resistor if L2 is kept the same. Yeah, part 4 was what is the voltage when you attach the resistor. So what's our answer for part 4? 2.19. Yeah, okay, so this is 2.19 volts. And so this one here is also 2.19 volts. And they want the current going through here. Do we know the resistance of this one?
Yes.
Yeah, what was it?
1.6.
No, 2.5. Thank you, Fahad. So 2.5, and then we have VI or, and what do I want? The I. So the I is V divided by or.
2.86.
Yeah, whatever, 876 if you want. Right, let's have a look at the next part of this electricity question. Okay. It's a fairly standard Kirchhoff question. Easy peasy. Yeah, so let's make the equations really quickly. Starting at the top, and we'll go around the outside loop. Okay? So let's write the equation down together. 10 minus 2. Oh, sorry, I'm going the wrong way around. Should be going to the left. Sorry, wait a second. Yeah. 10 minus 2.1 times 8. Now we'll go down the bottom. Minus plus 16 minus 6 I2 minus no, I don't know. I think it 2 times 2.1. That should equal
Minus or plus?
for the last one is minus. Yeah. Can we just write, oh wait, so this gives us I2, doesn't it?
Yes.
So I'm accidentally doing the second part first.
0.822.
So yeah, here we got I2.
0.822.
No, not this. 2.1 times 8 minus 10 minus 16 plus 2 times 2.1 divided by 6. What did you get, Tekken?
0.833.
Yeah, that's what I got as well, but the answer here is different. It's 1 point... This is I2, isn't it? Oh, I see what happened.
What do you got?
No, listen. I think there is a typo in the answers. His answer for I1 is the answer for I2, and the answer for I2 is the answer for I1. So I think what he meant on his picture was he wanted to call this bottom one I1 and the top one I2. Yeah? So it doesn't matter. That's why it's different. Sorry. So yeah, you said you got what value?
0.833.
And that's correct.
Yeah.
Part 1 solved. Well, what loop will I make next now?
So it's 2.1 minus I2.
Oh yeah, I shouldn't use a loop. I should use junction law. The junction law says 2.1 minus I1 minus I2 equals 0. But we know what the I2 is, don't we?
Yes.
So yeah, 2.1 minus 0.833. Is it 833, isn't it? Yeah. So what do we get?
1.267.
Ah yeah, so this is really easy. Right, last part. How can I get the E? What should I use? A loop.
16.063.
Yeah. let's use the loop. E1, what's next?
Going left or right?
Going right.
E1 minus
4
4
Times
I1.
10
Minus
minus 240.
Wait, are we adding or subtracting at the 6 resistor?
Mine. No, going the other way. Plus.
Correct. Plus 6
Times I2.
I2
Minus 3.
minus 16 equals 0. So what is the 4 times I1 minus 6 times I2 plus 16? What did you get, Token?
16.0.
Yeah. E1 is 16.1 volts. I really like the electricity question in the exam. I just think, with practice, it should be a 20 out of 20 mark question. Right, now listen, that was the first full exam we went through. So each exam will get quicker as we start to see similar things, okay? I'll give you the next exam paper. Let's have a look at it.